Hello everyone, I'm Yao Li from Chang'an University. In this lecture, we're going to learn some basic knowledge about Rankine's earth pressure theory. Rankine's theory assumes that soil is homogeneous and isotropic. Failure surface is a plane. Ground surface is a level. The back of the wall is vertical and smooth, where interface between the wall and soil is frictionless. The wall moves sufficiently to develop active or passive conditions. This figure shows coarse-grained soil under lateral earth pressure at rest. The wall doesn't move and the soil's small circle is within the failure envelope, meaning the soil is safe. This figure shows coarse-grained soil under active earth pressure at rest. The wall moves away from the soil on the right side of the wall. The effective horizontal soil pressure is decreased from the sigma h prime to sigma a prime. The soil small circle touches failure envelope, meaning the soil is failed. Here, the sigma 1 prime equals sigma v prime equals gamma prime multiply z. Sigma 3 prime equals sigma a prime according to the geometry of the Mohr circle. We know the relation between sigma 1 and the sigma 3, then we can get the equation 4, which can be used to calculate active earth pressure. When we define Ka as Rankine's active pressure coefficient, the equation used to calculate the active earth pressure can be simplified to equation 6. Active earth force is the area of the triangle, and its acting point is at 1/3 of h from the bottom. The angle between the failure plane or slip plane and the horizontal plane is 45 degrees plus half of the effective friction angle, as shown in the red figure. This figure shows coarse-grained soil under passive earth pressure. The wall moves towards the soil on the left. The soil's Mohr circle is within the failure envelope, meaning the soil is safe. When the wall continues to move, the horizontal soil pressure increases from the sigma h prime to sigma p prime. The soil's Mohr circle touches failure envelope, meaning the soil fails. Similar to equation for calculating active earth pressure, the equation for calculating passive earth pressure can be obtained according to the Mohr circle. After assuming the Kp, the simplified equation is obtained, as shown in the equation 6. The angle between the failure planes or slip planes and the horizontal planes is 45 degrees minus half of the effective friction angle. This figure illustrates the stress changes of the active earth pressure and passive active earth pressure. Cycle 1 indicated the state when the wall has no movement. It is within the failure envelope and it is safe. When the wall moves, the side where the wall moves away develops active earth pressure, and horizontal earth decreases to the Mohr circle touches the failure envelope. The side where the wall moves towards develops passive earth pressure. The horizontal earth pressure increases to the Mohr circle touch the failure envelope. This figure shows the movement of the wall. Where the wall moves away, there is an active zone. Where the wall moves towards, there is a passive zone. The slip plane for the two zones are different with different angles to the horizontal. When calculating the total forces acting on the wall, we usually calculate the area of the pressure diagram as shown in the figure with orange color. When the water table is below the wall bottom, the soil's effective unit weight equals unit weight. So the active earth force and the passive earth force can be calculated using the effective unit weight. Their acting point is at 1/3 of the height of the wall above the wall bottom. When water table is at ground surface, the active earth force and passive earth force can be divided into two parts, soil part and water part. For the soil part, soil's effective unit weight is used. For the water part, water's unit weight is used. It should be noted that Rankine's active or passive coefficient does not apply on water. The active earth force and the passive earth force are the sum of the two parts. Their acting point is at 1/3 of the height of the wall above wall bottom. When water table is between ground surface and wall bottom, the active earth force and passive earth force have two parts, soil parts and water parts. For the soil parts, soil's effective unit weight is used for the part below water table. Soil's unit weight is used for the part above water table. It should be noted that the soil's effective unit weight equals its saturated unit weight minus water's unit weight. For the water part, water's unit weight is used. The active earth force and the passive earth force are the sum of the two parts. Their acting points should be calculated accordingly. When there is a uniformly distributed load on the surface, Rankine's active or passive coefficients still apply. Corresponding earth pressure and force are given in the figure. Previous slides show the calculation of the active and passive earth pressure in coarse-grained soils. Now let's have a look at the calculation of active earth pressure in the fine-grained soils. In fine-grained soils, there is cohesion, as shown in the red figure. When the wall moves away from soil on the right side of the wall, the effective horizontal soil pressure is decreased from sigma h prime to sigma a prime. The soil's Mohr circle touches the failure envelope, meaning the soil is filled. According to the geometry of the Mohr circle, we can get the relation between sigma 3 and sigma 1 as shown in the equation 3. Substituting first two equations, we can get the equation 4, which can be used to calculate the active earth pressure sigma A. Substituting Ka as Rankine's active pressure coefficient, the equation can be simplified to equation 5. The left figure shows the stress diagram of the active earth pressure in fine-grained soils. On the Z0, below the surface, there is a non-contact zone as shown in the red figure, meaning the soil is not in contact with the wall. As a result, there is no lateral earth pressure in the section. The Z0 can be calculated when sigma A equals 0. Now in the stress diagram, the active earth pressure, active earth force, and its acting points can be easily calculated. For passive earth pressure in fine-grained soils, when the wall moves towards the soil on the left side of the wall, the efficient horizontal soil pressure is increased from sigma h prime to sigma p prime. The soil's Mohr circle touches failure envelope, meaning the soil is filled. According to the geometry of the Mohr circle, we can get the relation between sigma 3 and sigma 1 as shown in the equation 3. Substituting first two equations, we can get the equation 4, which can be used to calculate the passive earth pressure sigma p. Substituting the Kp as Rankine's passive pressure coefficient, the equation can be simplified to equation 5. Here are all the contents in this lecture. Thanks for your listening and see you next time.